So in matrix multiplication, that is multiplication of a matrix by another matrix, there is a certain rule to uh, have the resultant matrix. And what is the rule to maintain for writing the elements of the resultant matrix? That is how to multiply one matrix by another matrix. First of all, the important condition is when we go to multiply one matrix by another matrix, we have to observe first number of columns of the first matrix and number of rows in the second matrix. Number of columns of the first matrix, number of rows of the second matrix must be equal. This is the only condition. This is the only condition to be maintained, to be checked just before multiplication. When we have two matrices to multiply, first of all we have to observe number of columns of the first matrix. Suppose A is one matrix, B is another matrix, then A into B we need to compute. Then A is the first matrix here and B is the second matrix. So number of columns of the first matrix, that is A, and number of rows of the second matrix, that is B, must be equal. Just that this is to observe before going to perform. If equal, then it is allowed for multiplication. Here you see, notationally this one, you need not to think about this in terms of notation. Just through example, it will be more clear. For example, you see here, C is one matrix here, consider 2 rows and 3 columns. And D is another matrix, and D is another matrix, order different. Here 3 rows are here, 2 columns are here. So orders of the C and D matrices different. So it is not mandatory to be same order. But condition is number of columns of the first matrix, that is C, 1, 2 and 3. 3 columns are here. On the other side, the number of rows in the second matrix, 1, 2, 3. Exactly same. That means number of columns of the first matrix is equal to number of rows of the second matrix. That means condition is fulfilled, so it is allowed to go for multiplication. So C is given, D is given, we have to multiply CD. So C is the first matrix and D is the second matrix. So DC, we are not going to consider. We are not going to consider DC. We are going to multiply CD, that is C into D. Now, how to write the elements? The rule is this one. Observe very carefully here. This first one is C and second one is D. And here we have to multiply like this, first row into first column. It gives us first element of the first row. First row into first column, it gives one element, and this element is this one, A1, one position. So first row into first column, we have 1 into corresponding element, 1 into 2, minus 1 into minus 1, 2 into 5. So this means this one, this gives us only one element, that is first element of the first row. And we are multiplying by the first row, so we will get first row in the resultant matrix. So this is one element, that is A1, one element we have. So first what we have done, first row into first column, it gives us one element. Again, first row into second column. First row into second column. So there is no any other column in D. So multiplication by first row is over. Just observe one by one. First element, first row into first column is this one. And this result is, in the next step, if you observe, it is 13. And second element of the first row, question mark is here. That means how we will have this element. So this element we have by multiplying first row to second column. So first row into second column, corresponding element. That means 1 into 7 minus 1 into 1 and 2 into minus 4. And this gives us in the second step, you see. Second step, this is first row into second column. First row into second column. So this element is the second element of the first row. So first element we have got 13, and second element whatever we get simplifying this, it will be minus 2. Next step given. Stepwise it is shown for better understanding. Here you see first row into second column is this one. So that means what? Multiplication by first row is over. First row into first column, we have got 13. First row into second column, we have got this one, and this gives us minus 2. So since there is no any other column in the second matrix, so multiplication by the first row is over. First row into first column, first row into second column. So this is over by first row. Similar procedure we have to maintain for the second row. Now by second row we are going to multiply. So this is second row, 0, 3, 4, this is second row. Similar procedure, second row into first column, second row into second column. If we multiply second row into first column, similar way corresponding elements multiply. So 0 into 2, 3 into minus 1, 4 into 5. And this gives us this one, 0 into 2, 3 into minus 1, 4 into 5. So we have got this element. After simplification, we will get it is 17. Now, second row into second column. Second row into first column is done, and second row into second column we need to multiply. So similar way in the next step, observe. Second row into second column, observe the next step. So 0 into 7, 3 into 1 and 4 into minus 4. This gives us finally the last element, actually second element of the second row. That means the last element. So doing this multiplication by second row is over. Second row into first column and second row into second column, this is over, and we have got second row. If we multiply by second row, we will have the elements of second row. If we multiply by the first row, we will have the elements of the first row. So this 0 into 7, 3 into 1, 4 into minus 4, and this gives us result last element minus 13. So C into D, the result is this one, 13 minus 2, 17 minus 13. So this is the resultant multiplication, that is result of multiplication of the matrices C and D. So this is the procedure to have matrix multiplication. If you see once again, just observe carefully. First row into first column is first element. First row into second column is the second element of the first row. That means multiplication by first row is over. Similarly, Now by second row, we will multiply by second row. So second row into first column is this one, and in the last step, second row into second column. This is the second row. So we have to multiply by first row, we will have first row. If we multiply by second row, then we will have second row of the result. So this is the procedure to have the multiplication of two matrices. Now to simplify these steps, we can reduce definitely, because directly we can write multiplying first row into first column, first row into second column, second row into first column, second row into second column, so on. We can cut short actually. So in another example, you can observe here A is this 2 by 2 matrix and B is 2 by 3 matrix. So in the first matrix A, number of columns is 2, and in the second matrix, number of rows is 2. So column number of the first is equal to row number of the second. That means multiplication holds. Multiplication will exist. So now observe how to write the elements. Now AB, A into B, same way, first row into first column. First row into first column. That means what? 6 into 2, 9 into 7. This one. 6 into 2, 9 into 7. This is first row into first column. Now, first row into second column. 6 into 6, 9 into 9. So here it is written 6 into 6, 9 into 9. Another column is here. So first row into now third column. 6 into 0, 9 into 8. 6 into 0, 9 into 8. So now no any other column of B matrix. So multiplication by first row is over. First row into first column, this element. First row into second column, this element. First row into third column, this element. So since that these results are obtained by multiplying first row, so we have got in the result first row. So first row is over. Now by second row. Similar way, second row into first column, second row into second column, second row into third column. So second row into first column, 2 into 2 and 3 into 7. So these results definitely we'll have to write in the second row because we are multiplying by second row. So this position. So second row into first column is this. Now second row into second column. Second row into second column. That means 2 into 6, 3 into 9. 2 into 6, 3 into 9. Now second row into third column. 2 into 0, 3 into 8. 2 into 0, 3 into 8. So multiplication by second row is over. So that's why here second row is filled. So first row we have got multiplying by first row, and second row we have got multiplying by second row. So after simplification we have the result, and result is this one. 75, 1, 17, 72. Second row is 25, 39, 24. So this is the result of multiplication of the matrices A and B. So A into B is this matrix. So if you observe here, then A was 2 by 2 matrix and B was 2 by 3 matrix, but resultant matrix is 2 by 2 by 3. So this is the way how we can multiply two matrices if condition is satisfied. Here you see another example. Here A is 2 by 3 order, B is 3 by 2 order. Number of columns 3 and number of rows here 3 equal. So we can go for multiplication AB. And if we observe conversely, that is reverse way, B into A, then if we consider B as the first matrix, then its number of columns is 2 and A is the second matrix, number of rows is 2 and column is here also 2. That means BA also we can multiply. If we consider A as the first matrix, B is the second matrix, then number of columns of the first is equal to number of rows of the second. That means we can multiply AB. If you reverse it, that means B is the first matrix, then its column is 2 and A is second matrix, its row is 2. So then also we can multiply BA. That means condition is satisfied for both AB and BA. Now check whether A into B is equal to B into A or not. In real numbers, AB is equal to BA. 2 into 3, 6. 3 into 2 is also 6. And here in matrix, let's see how it differs. A into B here, this is A matrix and this is B matrix. Now we multiply this matrices. Then you can have the elements using the rules of multiplication. This is the first row, the first column. First row into first column. You have 1 into 2, minus 2 into 4, 3 into 2. So this element. First row into second column. 1, 3, the 3, minus 2, 5, the minus 10, 3, 1, the 3. So this is the element, first row into second column. So multiplication by first row is over. Now by second row we multiply. Second row into first column, second row into second column. And we have minus 4 into 2, minus 8, 2 into 4, 8, 5 into 2, 10. So minus 8, 8 and 10. So second row into now second column. Second row into second column. That means minus 4 into 3, 2 into 5, 5 into 1. So this one. And just after simplification, we have 0 minus 4, 10, 3. 0 minus 4, 10, 3. So this is the result of multiplication of A and B. That means AB is equal to this matrix. Now we perform this multiplication reverse way. That means B into A. B is the first matrix and A is the second matrix now. Let's see what happened. Now see B. Here number of columns 2 and number of rows 2. That means we can go ahead for multiplication. So similar way, first row into first column, first row into second column, first row into third column. So you see first row 2, 3, first column 1 minus 4 multiply. That's corresponding. 2 into 1, 3 into minus 4. That is 2 minus 12. So this 2 minus 12. Now first row into second column. 2 into minus 2, minus 4. 3 into 2, 6. Minus 4 plus 6 is this one. Now first row into third column. 2 into 3, 6. 3 into 5, 15. So 6 and 15. So 6, 15. So first row is over. So multiplication by first row is over. We have multiplied first row into first column, first row into second column, first row into third column. Now by second row, multiplication by second row. We have second row in the result. So second row into first column, that is 4 into 1, 5 into minus 4. That is 4 1s are 4 and 5 4s are minus 20. So 4 and minus 20. So this 4 and minus 20. Now second row into second column, 4 minus 2 minus 8 and 5 to 10. So minus 8, 10. Now second row into third column, 4 into 3, 12, 5 into 5, 25. It is 12, 25, 12, 25. So second row is over. Multiplication by second row is over. Now since another column, sorry, row is there, third row is here. So we have to multiply by now third row. Same way, third row into first column, third row into second column, third row into third column. So by third row we need to multiply now. So 2 into 1, 2 and 1 into minus 4, minus 4. So this is 2 minus 4. This is 2 minus 4. Now third row into second column. 2 2s are 4 minus 4 and 2 1s are 2. So minus 4 2, minus 4 plus 2. Now third row into third column. 3 2s are 6, 1 5 is 1, is 5. So 6 plus 5. So multiplication by third row is over. Now multiplication is over. First row into first column, first row into second column, first row into third column. Similarly, by second row and third row. So we have this matrix. After simplification, we got this one. It is 3 by 3 matrix. It is 3 by 3 matrix. And if you observe here, A into B, it was a matrix of order 2 by 2, and B by A, or B into A, it gives us a matrix which is of order 3 by 3. So obviously the results are not same. AB equal to BA we cannot say. So that's why matrix multiplication is not commutative. Commutative in multiplication means if A into B equal to B into A, that is called commutative. But it is not commutative in case of matrix. AB holds and BA also holds, but results are not equal. So A into B is this matrix, B into A is another matrix. So AB we cannot say to be equal with BA.
Sir,
Yeah,
sir, can you explain BA again?
BA.
Yes, sir.
Yeah, actually procedure is same. BA. Here you just follow multiplication. First row into rule is this. First row into first column, first row into second column, first row into third column, first row is over. Similar way, second row into first column, second row into second column, second row into third column, second row is over. Similarly, third row into first column, third row into second column, third row into third column, third row is over. Just that is the rule. First row into first column. That is 2 1s are 2, 3 4s are minus 12. So 2 and minus 12 is this one. Next, first row into second column. 2 minus 2 minus 4 and 3 2s are 6. Minus 4 6 is this one. And first row into third column. The 2 3s are 6 and 3 5 are 15. 6 and 15 this. So way of multiplication is exactly same. You have to multiply by the first row all columns of the second matrix. First row into first column, first row into second column, first row into third column. We will get first row. And similarly, if we follow by second row, so second row into first column, second row into second column, second row into third column, we will have second row of the result. So similarly, if we multiply by third row into first column, third row into second column, third row into third column, you will have the third row in the result. Have you followed it?
It's understood.
Yeah. You just carefully observe the numbers because these are only numbers. Just very detailed steps are written here in the previous examples. So order just you have to maintain. So automatically you will have the corresponding elements. First row into first column, only one element, first element you will be have. You will be having. First row into second column, you will be having the second element. First row into third column, you will have third element. Since we are multiplying by first row, so you are getting first row here. If you similarly, if you multiply by second row, you will have second row of the result in the resultant matrix. That means in the right hand side. So second row into first column, second row into second column, second row into third column. Now second row completed. Similarly, third row into first column, third row into second column, third row into third column. Third row completed. So that's all. So this is the way of multiplication. This is fixed actually. Just if you compute yourself, it will be clear within few minutes. The rule you have to maintain, and before going to multiply, just check whether number of columns, number of rows equal or not. Number of columns of the first strictly, number of columns of the first, number of rows of the second must be equal. So for convenience of remembering, you can remember the CRP. CRP. C means column for first, R means row for second, and P means permissible. CRP. Column of the first, row number of the second. And if equal, then permissible. P for permissible. Just for your convenience of remembering, you can remember so. And you can check yourself this one also, that A is this matrix, B is this matrix, AB is this result, BA is this. So clearly AB not equal to BA. You can consider any two matrices where number of columns of the first is equal to number of rows of the second. You can consider yourself any two matrix, and you can check. You can multiply AB. Small orders you can consider at first to reduce your confusion of order of multiplication. So with small orders like 2 by 2, 2 by 3, 3 by 2 of these types of orders matrix, from your side you can consider, you can multiply yourself AB, and again reverse, so you can multiply BA and check whether equal or not. Definitely not equal, so you can check yourself. So this is actually matrix multiplication. This is another example, it's a long example. Three matrices you can consider yourself. You can multiply one by one, A into B, B into C. Then you can check whether this property or not. So properties I will recapitulate in the real classroom, because here properties related things you will not understand clearly. So property related things I will definitely recapitulate later on. So these are actually basic simplification. Here A is given, B is given, C is given. That is, three matrices are given. We can check this property, distributive property, as we got in real numbers. Here A plus B, you can add A and B because their orders are same. So if we add AB, we will have new matrix, and that matrix you have to multiply by C. Then doing this, you will get one result, one matrix. And in the right hand side, you see separately if we calculate, that is A into C, and again B into C we can perform, and finally if we add them, that right hand side gives us another a new matrix. So left hand side gives finally one matrix and right hand side will give us another matrix. These matrices are equal. So that is we can verify here, and this is here it is verified in this example. Here you see AB. So A is this, B is this. So A plus B is just adding the corresponding elements. We have got A plus B matrix is this one. Now with this matrix, if we multiply by C, C is this one column matrix. This single column is here. So if this matrix A plus B matrix is multiplied by C, so what will happen? Multiplication holds here because number of columns is 3 and here number of rows is 3. So we can multiply. First row into first column, first element. So no column is there, so no need to multiply. So first by first row is multiplication is over. Second row into first column. Second row is over. Third row into first column. Third row is over because there is no any other column. Just multiplying one column, we get the element. First row into first column. So this is the only element. 0 minus 14 plus 24 gives us 10. So this element. And there will be no element in this position because no any other column is here. So first row into first column. First row into second column, but second column is absent. So first row into first column, that's all. That is multiplication by first row is over. Second row into first column, multiplication by second row is over. Third row into first column, so multiplication by third row is over. So finally we get 10, 20, 28. This is the column matrix we have got for A plus B into C. And in the right hand side's expression, if we follow up, then we will have right hand side was AC and BC. So AC multiply A into C, if we multiply, we get column matrix 9, 12, 30. And BC is another multiplication, B into C. So this result of this BC matrix is 1, 8, minus 2. Now in the right hand side it was AC plus BC. So AC plus BC doing, we have got AC plus BC. If we add these two matrices, we get this matrix, that is 10, 20, 28. So exactly it is same with the left hand side matrix. So left hand side matrix was the same, that is 10, 20, 28. That means what? A plus B into C is equal to AC is plus BC. That means if we add A and B, then multiply by C, whatever matrix we have finally is the same. If we add the matrices obtained by multiplying AC and BC, that means A into C multiplied, B into C multiplied, then added. So these two left hand side and right hand side matrices are equal. So it is clearly verified. So if we add two matrices and multiply then by C is equal to if we multiply individually, that is A into C and B into C. It is distributive property, you know already. In simplification in algebra you have done in real numbers. So A into C, this step algebraically always we used to write A into C plus B into C. So this relation holds in our algebra. We are very familiar with this expression in case of real field. But here also in matrix also this property holds. So this is all are related to matrix multiplication. So many verifications are there. So many simplification are there, and in matrix equations also we will be having this scalar multiplication and matrix multiplications. Whenever we go through some numericals, then we will be having okay, some network issue, someone is written here. Okay, that's all for today's session. That's a matrix multiplication. And next, we'll be discussing some basic numerical examples. Basic examples we'll be having, and we'll be discussing from the next session based on operations. And immediately after that, some new subtopic will be there: transpose of matrix, adjoint of matrix, inverse of matrix, and finally linear equations solution with the help of matrix method. These subtopics are there in this portion. So thank you so much